Okay, this is lesson 61, number 4, and it says, oh gosh, what does it say? It says a car has wheels that have a radius of 16 centimeters. And then it says, and the wheels turn at 40 revs per second. What is the speed of the car in miles per hour? So I would like to go to miles per hour. That's where I would like to go. And I know that linear velocity equals radius, isn't it, times angular velocity. Angular velocity is the speed in revs per second. Or is it radians? This is radius, right? And then, is this supposed to be this is radians per unit time, I think, right here. Okay, so we don't have radians per unit time right here.
But can't you add radians?
Yes. Now, it turns out that what's one revolution as far as radians go? 2 pi, right? So if you have 40 revs per second, you're going to have 80 pi radians per second. So we'll put that in for 80 pi radians per second. And then we can put the radius in as well. That's 16.
Because radians times radius is
arc length.
Oh, that has nothing to do with it.
Not with this problem.
That just popped into my
but
mind.
that was actually kind of in my mind too. It's kind of messing me up a little bit for a second.
Yeah.
All right, all we got to do, this is nice. All we got to do is get to miles per hour. So we can just kind of stick some stuff on. Oh wait, what was this? This was 16 centimeters. Wait. Why'd you guys mess it all up? I'm just kidding. Nobody messed it up. I put the centimeters down there. Don't do that. 80 pi radians per second. Sorry. You can see that I made a mistake. It was 16 centimeters and I put the centimeters down there for some weird reason. Okay, so now all we have to do is just put a bunch of unit multipliers until we get ourselves into miles per hour. So we can kind of, I know we're going to at least need a few. Now, like you said, radians can kind of go away. We can just, get rid of it. But we need centimeters to go away, and we need them to be miles. So we can go, centimeters per inches. Don't we know that 2.54 centimeters is 1 inch? And then the centimeters are gone. And then we can go inches to feet. And I know there's 12 inches in 1 foot. Now, feet to miles. Right? I know there's 5,000. Yeah. In 1 mile. So now my inches and my feet and all that. So that's all good. And then, but I don't have hours yet because I just got seconds right here. So now I have to make even more room. So, second. Actually, I can make more room because, see, I have more paper under here, so I can just run myself off the edge. Okay, so there's minute. So there's 60 seconds in 1 minute, and then I can just kind of go off on this other piece of paper and go minutes and hours. There's 60 minutes in 1 hour, and so all that gives me a grand total of, well, I've got 16 times 80 pi. We don't want radians, so we're just going to leave them off. Bye-bye, radians. And we got another 60 and a 60. And we got a mile. And I think that's about it for that. And then down here we got a seconds. We wanted seconds. Oh, wait. Seconds went away, didn't they? There they go. Sorry, seconds went away. We got hours. That's what we want. And so what else is down here? 2.54 and 12 and 5,280 and then just hour. Now I got miles per hour. So that's an okay answer with me. Your book has it written 2 ways. They have it written, let's check and make sure that's perfect. Yet they have it written just like that. And they also have it written as a decimal if you want to type all that into your... They're both bold, which means they're both acceptable answers. This is the decimal equivalent. If you did type that into your calculator, you would get this. Okay, I don't care which way you write it. this way, actually, if this way shows up somewhere on your paper, that helps me. At least I can, you know, give, especially if it's on a test, I can give you like half credits, or I can see what you did to get your number. Because if you just type in, if you just give me a decimal number and no work, and the decimal number happens to be wrong, then you're out of luck. You know what I mean? Okay, so let's